Today we're going to be looking at bubble sort. Bubble sort is an iterative sorting algorithm, which is a fancy word of just saying it goes through each element in an array. Okay, so now let's try and perform bubble sort on this array, and hopefully this should help us explain where on earth this bubble comes from. It's important to note that in order to do this, we usually have a temporary variable. First, we're going to compare these two values here. We have our 2 pointers. And we're going to be doing this in ascending order. So you can tell that 4 is greater than 2, so that's not correct. What we're going to do is we're going to swap these two values. I'm not just going to directly swap these. I'm going to take 4, assign it to t, and then this value then overwrites this index here. And then we're going to take this temporary variable here and then overwrite this index here. And now our pointers are now going to be looking at the next two values. We can see that again, these are not in the correct order. So we want to swap these again. I'm going to overwrite this value here with 4. So remove it, and then overwrite it, and then overwrite it with 4. And then we want to copy this value over here and overwrite it. And then we take this value again and put it here. This will become 4. And then, like last time, we want to shift over our pointers. So we're going to be looking at these two values again. So 4 is still greater than this number here. So we write 4 into here. And then we overwrite this 4 with 3. That goes into there. And we'll take this value again and overwrite this second pointer. And then we want to shift over our pointers again to the next two elements. So now we're going to be comparing these two values. But unlike last time, you can see these are already in order. 4 comes before 8. So that means we've now done our first pass of the through the array. So now you can still see that this is not in order yet. So we go back to the start. We do it all over again. I'm going to speed this up because I don't want this to take up the whole of the video. Yeah, we take this value, put it here. Then I overwrite this 2. I take this temporary value and overwrite this the 1 there. And yeah, now you can see that we've sorted the whole array, but we still actually have to go to the end of the array and check that it's all sorted. So now you can probably see that the bubble part comes from the fact that you, I guess, bubble through the array, comparing these two values, then these two values, then these two values, and lastly these two values. This usually takes multiple passes, especially for really large arrays. Okay, so let's go about trying to write the pseudocode first before we actually try and code it in Java. In order to keep track of whether we've swapped any elements in the last pass, because if we've done no swaps in the last pass, then it means that the array must be sorted as nothing had to be changed. In order to check if there have been no swaps in the last pass, we can use a simple boolean to act as a kind of flag. And I'm going to say that swapped is true. Then we're going to loop while we did a swap in the last pass. We're going to assume that we didn't swap anything until we actually need to swap something. We'll loop I from 0 to array.length minus 2. This minus 2 comes from the fact that if we have array and then we have our indices here, we want to make sure that we stay in the bounds of this array. We don't want to be checking a value that's somewhere off over here. So this I, since we're comparing two values at a time, and this I is going to represent the lowest value, you can see We compare these two, we have 0 and 1. Compare these two, 1 and 2, 2 and 3, 3 and 4. The length of the array is actually 5, and we only went up to 3. So 5 minus 2 will give you 3. And this will go for any length. It will always be 2 less than the length of the array. And we want to check if array I is greater than array, we're going to say I plus 1. So we're overwriting, we're keeping track of the left value, and then we overwrite the value at that index in the array with the one after it. Then we take our temporary variable and put it into the index afterwards. So then we performed a swap of the two elements. And then we can't forget our swapped flag, true, because we just performed a swap. There we go. And this is our pseudocode here. Let's try and do it in Java next. So first we have to define our array. Then we have our swapped flag here. And then we have our outer loop while swapped. Then our nested loop. Then we have our check to compare the two values. Then we want to store the value there in a temporary variable. Then overwrite the value at that index with the one afterwards. Then overwrite the next value with the temporary variable. And we want to say swapped is true. And that's our whole algorithm. So I went ahead and wrote a helper function for converting an array to a string. It's the same function, just I added some print lines that will show us the progress as it goes through. There we go. Now you can see we start off with the unsorted array. Then after the first pass, we already have 3 and 4 in their correct positions. Then the second pass, we have 1 and 2 in the correct position. And then we do a final iteration and see that there's been no changes made to the array. And then we can safely exit knowing that we've sorted our array. You can see we have 1, 2, 3, 4, and 8.